Hello, good afternoon, and welcome to another fresh session from us about a very different topic compared to what we have been doing in the past few weeks. It is about how are we planning the meeting spaces or workspaces in the coming days. My name is Devraj, and today's session is in association with Contract and Commercial Design. Basically, they're a platform for a B2B platform for design spaces and designing workspaces. So in today's session, I'm joined with Fali, who's moderating the session, my colleague who looks after the Pro Audio market development. I look after the market development for systems at Shure South Asia. And just a bit of a housekeeping for today. Most of you would be seeing a screen like this. It's a Blue Jeans event, a webinar page. And it's a broadcast event wherein you would be able to hear me throughout the presentation along with the slides that you're seeing. If you have any questions during the session, you have a Q&A bar on the right-hand side. Just put in your questions. If you have any comments which the moderator can address, you can put those comments there as well. And your questions would be addressed at the end of this session. So quickly looking at what are we covering today. So for those of you who do not know Shure, just a quick introduction as to what we are, and we'll quickly jump on to then discussing about some evolution of workspaces in the past couple of decades and how actually acoustics play out in these workspaces. Recently there has been a lot of proliferation of virtual collaboration tools or collaboration tools basically to be able to meet across geographies using these meeting spaces. So how are all these coming together and what are the dependencies, what needs to be considered is what we be looking at in the end of the session. And after that, if there are any questions from your side, we would be happy to address those as well. So a little bit about Shure. It's a US-based company, primarily manufacturing microphones for over 90 years. We have been into the live sound industry for quite some time, and then we have been into the corporate space, having specific audio solutions being designed for meeting rooms as well. Some of the spaces that we have the solutions for is that what you see in the screens, live sound, boardrooms, and even for musicians and artists as well. So workspaces, this is something what we are focusing on in today's session, and how have these spaces been evolving over since the beginning of the meeting spaces coming into existence. So as we can see that meetings used to happen, or meetings started in a way which was very personal. People used to come and sit together, discuss their ideas, have their way of collaborating using whiteboards or flip charts, and then having a discussion amongst themselves. So a very simple way to meet in the beginning. Then eventually when that concept grew, you saw the meeting rooms evolving with larger spaces, and the flip charts or the presentation board that you saw before, that also evolved. So we had projector screens and maybe smart boards also coming into the meeting spaces. And then there are some more polished spaces wherein you have better seating, you have better lighting, just to make the ambience feel nice and be more comfortable for longer durations, right? So this is how we've been seeing how meeting spaces have been evolving. Some of them that you saw till now were neatly designed, and some of those we see are focused purely about how people can sit together around in that space. And the reason I put this picture is to be also visually give an idea as to to make you think that what this room experience would be compared to the earlier pictures you saw. Yes, a lot of people can sit, but how comfortable would this be compared to the earlier rooms is something that that one can imagine. So I will be continuing with this evolution of meeting spaces a little bit later in this session. This is just a small preview of the different types or the how the meeting rooms evolved till a certain point of time. What's very important, in a meeting and even now is that intelligibility of the person speaking. If you are not able to understand me in this session, then it would not be easy for me to pass on the idea to you, or whatever I want to converse. It'll be a difficult conversation. So speech intelligibility is very important when it comes to meeting spaces, and acoustics play a big role in ensuring that the speech intelligibility is taken care of, right? So what are the different angles, what are the different dependencies, challenges when it comes to acoustics, right? So let's first look at what challenges do we face. And the graphic that you see on the screen right now is basically an example of how the energy of audio, energy of speech travels in a room, and how it behaves based on the surfaces in the room, and how does it affect the intelligibility. So this basically clearly indicates as to how it travels in one direction, how it gets reflected, and the picture below can show that how much of copies of the primary speech can be created, and I'll show you an example of how it actually sounds when it is in a very reflected environment. So this is one of the challenges that we see, and then there are ways to basically define them, right? Science and physics give us ways, and that's how we have learned to understand acoustics. So one of the very key term that we come across, and we kind of keep educating our partners and customers, is critical distance. Some of you may know about this. It is simply put, it is a distance wherein the direct sound level, let's say when I'm speaking, that's the direct sound is equal to the reverberant sound, or the reverberant sound is equal to the direct sound. That's where that's the maximum of the critical distance. Beyond that, the reverb would take over, and your direct speech would get affected. To show an example, right now I'm very much you're hearing me through a microphone which is very much within the critical distance. Just imagine you are in the room with me, and you're right next to me. But if you're away from me, for example, in a room like this, right? So now you can see that my primary sound waves are not hitting you directly. It's all the reflected waves from the room that I'm in. I've tried to kind of replicate the experience that you would get when you're standing in this room. So it's quite challenging, right? This is something on the extreme level, the picture that you see, but you do see this kind of experience in some completed meeting rooms as well, right? An example would be a picture like this, wherein you have a very neatly done room. However, there are a lot of surfaces which can give the same effect like an empty hall. You have the glass surface, you have the hard flooring, you have the hard table. All of that can result in the same experience as you heard before. So that's the difference when it comes to considering this particular phenomenon in acoustics. That's just one of it. And there are solutions to it as well. So in order to be able to suppress all the reverb noises, traditionally we have been seeing that there are acoustic panels in place of different kinds. This is an older way of handling an acoustic signature of a room. There are some newer ways, or there are some optimal ways, let's say, to have acoustic panels in place so that the large reflective surfaces are taken care of, and they have these acoustic panels which kind of diffuse the reflecting sound waves coming inside this room, right? In the modern world, you would see that aesthetics is also considered when a meeting space is prepared. So you don't see that the acoustic panels are out of place, but they gel with the theme of the design, right? So this is one of the modern solutions. And when it comes to bigger spaces, and once you have to consider the number of participants that has to be accommodated in that space, the acoustics, obviously, as all the points that I mentioned earlier, need to be considered, and it has to look good as well. So these are a few examples wherein a large space with many participants has been considered to not only look good but also sound good as well. Now, another concept wherein even with the pictures that I shared before, the large spaces with good acoustics, what can happen is that when imagine a person sitting at the one end of that room, let's consider the bottom right picture, right? You're at one end of this table, and the person who has to listen to you, some of them are at the other end of the table, right? So what happens is, this concept of inverse square law is basically, coming into picture, and the person sitting further away from you is losing the energy of the audio that the person was speaking, is losing 6 dB for every square of the distance they are moving further away from the talker. So this concept is called as inverse square law, which is basically applicable to direct speech, applicable to a reinforced speech if you're hearing that person through a speaker or any other medium. This basically applies to any kind of energy that has to travel, right? It's not only applicable to sound, it's applicable to other means of energy as well. But since you're discussing acoustics, it's very much important to consider this particular concept as well. Now, when it comes to meeting spaces, there are some very common noise sources that we see, right? We have the HVAC noise, we have some of the equipment noise coming in from the rack sitting in that meeting room. That rack may be for the display, it may be for the sound system, projector system, control system. So all that needs cooling. There are fans in it. So coming together, that rack will have multiple equipment. It will create that noise. If the building is next to a busy road, you will have all the traffic noise seeping through. So these are some of the noise sources that you typically see in and around the workspaces. How does it affect, again, the audio signature of that place or the acoustics of that place? Again, it can be related to the term in science is called as signal to noise ratio. So what you're hearing right now is a good signal to noise ratio or an excellent signal to noise ratio, wherein you're hearing me very clearly, but you're not hearing other ambient noises. I'm sitting in a home office. And I'm actually, my building is right next to a busy road. So you would probably not hear a lot of traffic noise, which I'm hearing right now. My fan is on. You're not hearing that as well, because the technology that I'm using is ensuring that the signal is much better than the noise, right? So that's where it, this is also one concept wherein you have to consider that, what is this ratio? If the noise is higher, the noise goes higher than your signal, then imagine if I have to speak above the noise, I will have to raise my voice, just as the way you would you would be speaking to somebody just before boarding an airplane, right? So that's basically a bad signal to noise ratio, or you have to boost your signal compared to that noise. This is also a concept which needs to be considered. So the noise sources, how they can be mitigated, how the signal can be improved, or how the talker can be less fatigued when he's talking in that meeting environment. So to mitigate all these, the noises, and in large spaces, you usually see a solution for sound reinforcement, right? Which is basically a way to reinforce your audio or amplify your audio using technology, using an audio solution. And those audio solutions or reinforcement solutions can be of different types. We'll discuss, or we'll see the three major types that we see most commonly being used in meeting spaces. So let's look at the type one, which is, the picture is very basic for you to understand that the most common and the very commonly used popular sound reinforcement system would be a microphone, or multiple microphones going into a mixer, amplified, and then going to loudspeakers. This is something that you would see in a typical PA system, and it can be a wireless one or a wired one, and comes in different form factors. So this is one example of the type one of the sound reinforcement. Type 2 of the most common one would be a little bit more sophisticated on the next level, wherein you have an all-in-one conference system. Some of you would know that there are these dedicated conference systems which come with a built-in microphone, speaker. They all go daisy-chained into a central server, and then you have all the earlier jugglery that you saw with the Type 1. It gets a bit more compact, and then you have it rolled about. So it looks something like this when it is deployed in a large meeting space. So it's all cabled in a daisy chain way, and then you get to give a microphone and a speaker to every single person without having to go for a rack-based solution. And then there is Type 3, which is new, which is latest, and which is also very hands-free, right? So you don't have to have a handle, you don't have to have a microphone on the table. It can be somewhere else in the room where you don't even need to see. You just go about doing your job, doing the presentation or asking questions without having to worry where the microphone would be or where the speaker would be. An example would be a classroom like this, wherein you have the microphone, you have the speaker, and you have all the mechanism to reinforce audio. You just don't have to worry about it, the product in front of you, the technology in front of you. Just focus on your classroom or you focus on your session, and then just walk out. So that's basically the Type 3 or the most modern way of doing sound reinforcement. Now, till now, we spoke about the in-person meetings or the different types of rooms accommodating the number of different peoples coming in that room. Now, same type of rooms, when they connect to another geography or another location, we come to the virtual meeting concept, which basically means that all the solution that we're talking about has a camera or a system added to it, or a codec system added to it, wherein you are able to pass on all that audio and video feed to the remote side, right? So this is basically the concept. That's where you have the key components in place: the camera, the microphone, speakers, and the display for the visual and hearing perception. Coming back to what I began with in the beginning of the session as to how did the meeting spaces evolve. So when technology came in, it first came in as to enable audio between different spaces using an audio conferencing system. Then came audio, wherein people could interact in two or in a better dimension than just audio conferencing. And when it came, it was also understood that the way people are able to interact face to face using technology, it can be replicated quite in a near perfect way, as a face-to-face interaction, right? So virtual meetings, you saw different types of rooms, wherein it can be a simple boardroom, or it can be a training room like this, wherein people get to see the remote side over video. But at the same time, it also matters as to how this virtual meeting concept is being provided to the audience for adoption, whether they'll, how would they adopt it. Now, this is an example wherein you see a huge meeting room, and you have your technology at one end of that room, right? So all of the participants are required to look at that one side, and I mean it's perceivable as to now what would be the experience of the meeting here compared to the experience of the meeting in this room, wherein it has been ensured that there are enough people, and as per the number of audience, as per the distance from the person that they have to see, the size of the screen and the type of the content they have to view is also taken care of. So this is basically how we are handling the perception of vision when it comes to virtual meetings, or the ideal way of handling perception of vision in virtual meetings. For us, the perception of hearing also matters, and it is equal, for compared to the perception of vision. So, because for our senses to be able to coordinate well, it has to both, visual as well as audible as well. So all these concepts that I was talking about before, regarding the critical distance, the inverse square law, and the signal to noise ratio, they all apply to the meeting technology as well, right? So for that, when you have spaces wherein you have the type 1 sound reinforcement system, which was the traditional one that I spoke about, they can be integrated with the video conference system. Same goes with the type 2 one. The conference system, or the digital conference systems, can integrate with the video conference solution, or even the hands-free solution, which is the voice lift one, can also have an integration with the virtual meeting or the video conference setup, right? So it's possible. It's just that we need to consider which room needs what kind of solution and how it has to be integrated. So coming back to how the rooms are designed when it comes to spaces where virtual meetings are not required and spaces where virtual meetings are required. The left-hand side is the one wherein it is in-person meeting space. There is no technology, but it is really designed well to have a good ambience, both in terms of visual as well as the audible ambience. On the right-hand side is where you have the same type of room but with technology, and I will leave it to you to think as to how much of this you accept in terms of aesthetics, and how much you would let go, or how much you would really not accept at all, right? So this is one of the ways that technology is used in meeting rooms. And there is another way of having technology being placed in meeting rooms wherein it does not intrude the use case, or intrude the workflow of the end user. That's number one. But it also does not intrude into the aesthetics of that room, right? And it is possible. So it's only a matter of what is being considered at the right time to enable that the space is to enable the space for the best, the most productivity, right? This example is where you see that all the aspects that I was talking about, visual and audible perception or sound perception is what is considered in this space, wherein you see a screen which is basically showing all the video and content which is comfortable for viewing for the audience, and for the audience to be able to interact in that session. You have that technology in place as well. You have the microphone in place here. You have the speakers in place, but you do not see it, right? That's the beauty of keeping with the new trends of adoption of enablers in these meeting spaces. So in this example, we're basically showcasing a microphone which is not on the table, but it is on the ceiling, and it is placed in such a way that it comes nowhere in the picture when it comes to use case, and it can be flexible in different ways, right? If you want to change the seating from a boardroom seating to a classroom seating, go ahead, do that. There will be no cables, no hindrances compared to the traditional approach of having a wire coming in between, right? So another example is a room like this, wherein again all the aesthetics are considered, and you basically do not see technology intruding the space that is designed for human beings. This is one more example wherein the virtual meetings are set up in a custom way, and also in a way which can change its layout, its seating layout for tomorrow. Again, whatever was the technology when it comes to interaction of the audience with the virtual meetings, it is not coming on the table. So you're free to move the table, you're free to keep your important belongings on the table, and not basically disturb the aesthetic feel or aesthetic theme of the room. Again, here the microphones are up on the ceiling, and everybody's covered, and then everybody's able to speak to each other, whether within the local space or virtually through the video conference system. Another example wherein the new concept can help people sit in different ways, in different layouts. For example, Scrum spaces, Agile spaces. You can see that based on the size of the room, there has been enough AV considered so that it is easier for people to switch their seating, change their layouts, but not be away from the content or the idea that is being shared in the meeting. And especially coming to speaking about the current situation or the world moving forward, we will have to reconsider personal space, and that's where again the traditional concept of having seatings tagged together, or typical concept may have to be relooked at. And this is a picture which gives the exact example, which allows people to collaborate, be in the same room, but be away from each other at the same time. And this is also possible because they are being picked up from a microphone which is placed above the room, right? And it is capable of picking up all the audience, just as the way the camera is picking up all the audience. The same concept is now available for a microphone which traditionally needed to be in front of that person on the table. So that can be avoided. The distancing can be maintained, but does not affect the productivity or the output of that particular meeting. So just to come to the cycle of how a space is designed, we all know that it is a designer looks at a space, takes the end user's input, saying that, okay, what is the theme that they're looking at, what is the space they're looking at, how many people, and based on that there is a design concept made. And in that design, we consider some of the key components that needs to go into that building, in that room. It's basically the lighting, the HVAC, the fire suppression system. So these are basically what are primarily discussed before a room is set up. But as we all see that the room also has a good amount of AV component going in. So once the requirement is coming in from the customer, the spaces are designed, the infra is considered for the necessary or the traditional necessary equipment. We also have to consider AV also as a necessary component or the necessary infrastructure going in for that space. So that's where the true integration is, where the person designing the space, the person providing infrastructure for the spaces, it can be the HVAC or the power infra provider, or it can be the AV infra provider. If the integration happens between all these three parties, that's where the spaces would be would not only look and feel much better, but they'll also have the experience, both in terms of visual, but also the overall the experience of that room can be much improved, both for in-person meetings as well as for the virtual meetings as well. So that's with that, I would like to jump onto some questions if there are any, and I would check with Fali if you have any questions that we can address.
Dave, we don't have any questions at the moment. And for all those that are attending, in case you all would like to ask any questions, then you can use the question and answer panel and type down your question and we'll receive it and ask. In the meanwhile, Dave, the videos for signal to noise ratio are up. Would you like the audience to just listen to those now?
Oh yeah, perfect. So yeah, let's do that. So just to help the audience understand, we tried to upload the video or a file which basically shows the example of all the points that I mentioned before regarding the critical distance, signal noise ratio. To better understand, it has been uploaded now. So, Fali, if you could just go ahead. What I can do is I'll quickly go to that slide so that it is easily. Yep.
Yeah.
So you can critical distance one.
For everyone that's hearing it a little soft, maybe you could just take the volume on your device, your phone or your laptop, just take that to full just for this one so that you can hear it more clearly.
This is how the talker would sound to you if you are either at the critical distance or lesser than that distance. And this is how the talker would sound to you if you are beyond the critical distance. So let's now look at
signal to noise.
This is an audio sample which shows an excellent signal to noise ratio. And now the signal to noise ratio is poor. And now the signal to noise ratio would be much worsened. So I think, yeah, this file came out to be much better. I guess it gives a much better picture of the concept that I was talking about, in terms of how audio can be affected in different ways in a room based on different factors. Come to.
We have a question. And firstly, Mr. Akshay Kumar thanks you for a wonderful presentation and wants to know what is the role of a project manager in an acoustic company and how the quality can be improved, maybe because of the project manager.
Okay, so it's a good question. Actually, you're hitting the right point there. When it comes to project management, this is one area which is when it comes to acoustics, when it comes to audio, is where we see lack of awareness. So that's something a project manager can have, as an addition to the rest of the infrastructure arrangement that they are planning for. Is not only look at the visual aspects of it, but also measure how would the room sound when the room is complete. What are the materials that are being considered? What are how big is the space? How many people are going to sit? Including people, that also is to be considered as to how the behavior of audio in that space would be. So there are ways to measure, like all the concepts that we demonstrated to you. These are all measurable, and there are tools to be able to understand it. Just as the way you would measure the lighting of a room, that how many lux levels of light do you need. The same way the audio signature of the room can be defined, and that's what should be also part of the project management, to have the right room in place.
Yep, great one. There's one more question, and the question says, and actually, a question that's perfect and very relevant for the times we are in now. What's the purpose? What's the solution that we can propose for a work from home scenario, and how does one resolve acoustic issues when you're working from home? Yeah, great question.
Yep, excellent question. See, to answer in a nutshell, it's the best way to have a good work from home setup is to ensure that you're using the right components, just as the way you would ensure that you are presentable to your to the person speaking in an in-person meeting. The same way needs to be considered for the virtual environment, and for that there is a certain type of solution that helps make it sound much better. Like right now, you are hearing me through a gooseneck microphone. Now, why gooseneck microphone is because gooseneck is the gold standard for microphones, and that's why even in this home environment, you don't hear any other ambient noise. Now, many people don't know that, and you actually don't need a gooseneck microphone at home. But there are once you research enough, you will find the right products. Shure has USB microphones which can make it sound much better than a webcam-based microphone or a built-in microphone of a laptop. So this is something that needs to be considered. That the critical distance part, what I spoke, actually comes in quite a bit when it comes to home conferencing, because when you're using a laptop, when you're using on an office desk or in a space, and you're away from that microphone, that's where the reverb, all the extra noises that come in. So you need to mitigate that, and you need to have the right product placed properly, so that the experience that you got just now can happen in every house. It's just that the right solution has to be placed, and it generally doesn't come built into any hardware. You need to pick up the right solutions for that.
If I may, I can just show a couple of the pictures of the USB microphones that we have, since that question has come and it's quite relevant for now. So let me just share my screen.
So let me see.
Are you able to see the MV51?
Yep, we can see that.
Yeah. So here are some of we have various products that are used for everything from making entertainment to work from home kind of scenario. So the MV5, MV51, MV88 Plus, the MVI, and just for your information, I am currently using the MV88 Plus. So you're hearing me on that at the moment. So this is the MV5. It's a tabletop kind of microphone, and USB connects into your laptop, and you can connect your headphones over here. You can also use this kind of a scissor stand. This is the MV51. Has a few more features than the MV5. This is the MV88 Plus. So this product has become very, very popular. There are multiple features to control to an extent, to control your room acoustics. Just to, you can narrow the pickup angle so that it rejects noise that may be at the back or maybe coming from the sides of the microphone. And this is a little sound card that you can use to connect a separate microphone if required. So yeah, I mean, we have a lot of solutions for the work from home scenario to get good audio. And I think the most important is even in my room, I'm actually in my spare bedroom at the moment, but just drawing your curtains, or I have a small like a carpet on the floor, can remove a lot of those reflections from the room, so it can make your audio far clearer. So few things like that can be adopted. We have one more question, and that is actually there's one more question again related to work from home scenario. So I hope those few presentations the few pictures that I showed you are fine. You can also get in touch with us. Dave, you have the slide for people to get in touch with us regarding work from home solutions, and we can tell you where to. We can put you in touch with the correct dealer in order to get them. A question here says, a lot of companies talk about an open plan, hexagonal meeting room kind of design. So what would be the best thing to adopt from an audio perspective in order, and what kind of materials would you use to design these kind of rooms so that the audio is, the audio gets picked up and is yeah, intelligible basically?
Okay, so I'll dissect this question into two parts. One of it is that we can provide a solution, and one of it is that we can recommend that what should be done to make the room sound better. So I'll start with the latter part. Is that now there are, again, like I said, there are ways to measure acoustics as well. So when you're building a space, there are multiple types of materials that can be used. I would say the acoustic consultants would be the right contacts to suggest what to be used in what kind of space. But in terms of what were the values that should come out when those materials are in place is, we call it in terms of measuring the reverberation or to have the right levels. We call it that the RT60 value of the room should be less than or equal to 500 milliseconds. Now, if that sounds a mouthful, it basically simply means that the reverb effect, the reflections that you hear, if you remember the empty hall that I was showing, that happens in meeting spaces as well. So that reverb effect should be limited. We cannot make it zero; it will be sounding very dead. That reverb should be much lesser, and that's the RT60 value that I'm talking about. And it should not, definitely not exceed 600 milliseconds in worst case scenario. This can be measured. There are tools to measure these RT60 values as well. And whatever materials you use, be it carpet, simple curtains, less reflective table surfaces, it all helps to come to this figure. And once that is there in place, we have the solutions to be able to ensure that, especially the solution that I showed in one of my last slides, like for example, this kind of space. We have the microphone which can pick up from any area from this room. The microphone that you see is on the ceiling, nothing on the table, nothing on the wall, but you can have any area being picked up from any of the space. Right. So, and the way the products or the solutions are built is, I also I saw the question somewhere that whether it is whether are we looking at feedback, because we have the speaker also on the ceiling, we have the microphone also on the ceiling. That's where the actual technology comes in. So the way we have designed it is that if it is picking up, at that person, just as if you can imagine a ray of light, right? A focus beam looking at that person, that's how the microphone is picking up. It is not listening to the output from the speaker. So that's why we are, first of all, physically being able to reject a lot of that feedback situation, and plus we also have processing, which even if the signal comes in, we can tell the mixer that we don't need to process it. It doesn't have to go back to the speaker again. So that's where we can avoid the loop back effect as well. So this is one example. This is another example I showed just to be able to give that different kind of spaces can be covered as well. One more thing is that we see that traditionally table or ceiling is the space that is that can be used, but we are coming up with more options wherein you will see you can also use a wall to keep a microphone. So that's something we would be launching soon next week. So stay tuned. If you have registered, you'll probably also get communication for those solutions as well.
There are some more questions. One of them, Mr. Ahmed wants to know what mic am I currently using. So I was using the MV88 Plus. Yeah, so it comes with a tripod and a phone stand, and on top of the phone stand you can fix the microphone. So that's what you're currently listening to me on. There's another question with regards to if the microphone and the speaker are integrated together in the ceiling. Firstly, how do we avoid echo? Do you require some sort of manual intervention in order to make volume adjustments? And will a standalone microphone be required when a VC is done in the same room? So there are 3-4 parts to this question. You can start with the first one, which is how can you avoid echo? How is the echo avoided if you have the microphone and the speaker in the same form, basically?
Yeah, so it's basically, we call it acoustic echo cancellation if it is a VC call. And it is also possible if there is a local reinforcement happening. So it's basically the processing capability. Both the products, the output and the input, basically the speaker and the microphone, they are interconnected, which means that the microphone can be told that this is the frequency coming out of, this is the signal coming out of the speaker. If you hear it, just cancel it out. You don't have to process this again and send it back to the speaker. So that's how the feedback is suppressed. And same way, acoustic echo cancellation, which is to do with the VC calls, is to do with not letting the remote audio or the far end audio come out from the speakers in this room, go back to the microphone and hear that person his own audio back again. That is feedback. So feedback or acoustic echo. So this can also be addressed by the processing capability. So we can tell the system that this is the signal coming in, you listen to it, but you don't send it back. So that's where it cancels out that frequency, and then that's how it is addressed. So it's called as acoustic echo cancellation for VC, or feedback suppression for in-room reinforcement.
Okay, the second part of the question is, do you require some sort of manual intervention to make volume changes in the speaker?
You can if you want to, but if this solution is rightly put up, if it is rightly configured, rightly provisioned, you actually don't need to touch the audio setup at all in that room. In fact, if the AV is done really right, if considering all the user requirements, the ideal way would be that the user just walks into that room, starts using the room, and then walks out without having to touch anything in that space.
Yep. The next part is, supposing you require a standalone microphone, like when a VC is done in the same room, like similar to kind of the meetings that we do sometimes, where you have a standalone cordless mic or something. How would you integrate that?
You can, if you want to use a standalone microphone. They all go into a mixing device called as a mixer. So whether it is a different kind of microphone that can be ceiling, the table ones or the handle ones, all the channels go to a mixer. The mixer mixes it and gives it to the VC device, let's say. If at all that is required, it's possible. It can be a wired or a wireless microphone, or any kind of microphone. They all go into a mixer, and that's how the patching works.
Okay, and does this completely avoid the use of acoustic panels? Using a system like this, would you avoid the use of acoustic panels?
I wouldn't say that you can avoid the use of acoustic panels, because, like I said, any audio product, any environment needs acoustic treatment, right? Acoustic panels are there to avoid all the, remember the physics I was talking about, the signal noise or the critical distance, the reverb part. You need to control that. No technology can control that. Reverb cannot, reflections cannot be controlled by technology. Just as the way, when you walk into the empty hall, your brain cannot process that audio. The same applies to the products as well. So you need to first control that space, control the acoustics of that space, and that's why acoustic panels are good to have. It should be there if the room needs that treatment, and letting technology address that. It may be able to suppress a little bit, but it would not be good for the nature of the audio that it will generate. So that is why physically it should be addressed using the panels rather than letting the products handle that.
Okay. How does a low ceiling affect the sound in the room?
it depends. Like a low ceiling can have different effects depending on the length of the room. In fact, the type of ceiling, the length of room, the height of the ceiling, all that affects in some or the other way. I've been in one of the rooms where the room was really long. Let's say longer than the one that you see in the picture. So it was double that distance, and it was used like a long boardroom. Now, what I observed in that space was that the room had its own gain. So if you speak it from one end, the audio would reflect multiple times, and by the it reaches the other end on its own. So some places it actually did not even need that technology, and it had its own room gain coming in. Same can we have seen a very low ceiling affecting audio in a different way when the microphone was placed there. So it was a wrong choice to place the microphone there. It should have ideally been on the table, and that's where the pickup got affected. If the ceiling has HVAC vents on the ceiling itself, then the noise, you're very close to the noise source also, so the signal would get affected there as well. So yeah, I mean, it's not just ceiling; it's many aspects in that room which can affect audio.
That is it. We have one more. I think we have time to take one more question, and that is reverberation good for sound quality before the critical distance?
Reverberation good for the sound quality before. So critical distance says that if your energy of speech or the primary sound wave that hits your ears, or let's say the microphone, is equal to the energy coming from the reverberant waves, you're good, right? You are at the critical distance there. But if the reverberant wave hits your ears first rather than the primary wave, that's when it is not good. And that's where you're beyond that critical distance. So you should always ensure that you are within either at the critical distance or within the critical distance. Reverberation should not come first, because reverberation is not just a single wave, it will be multiple waves coming to you, right? So multiple waves means you can imagine how it would sound in an empty hall, and how you would converse with the person standing in an empty hall if he's 50 meters away from you, or 10 meters away from you. You would not want to have a long conversation in that situation. So I hope you get that message.
Cool. Yeah, I think that's it, Dave. I want to thank everyone for joining us. Any last words from you, Dave?
Hey, Fali, we have one more
Hey.
question. I'll just quickly say it so that we can save time. The question is, have you worked on large corporate office projects? Can you share an example of one such project?
Yeah, we have actually multiple, wherein the concepts what I spoke about have been actually deployed, both voice lift as well as conferencing. I'm not sure if I can name those projects here in this forum, but if you could connect with us one-on-one, I would definitely be able to share those details. But in general, I can mention that our customers here in India also include the software sector, the the banking sector, even manufacturing. So all these sectors have been, in fact, even one of the PSUs, one of the pictures that I showed is the last ones is one of the educational institutions as well. So the one that we show you here, this is actually one of the management institutes in India, which has the voice lift system in set up here, wherein you see the ceiling arrays, you see the ceiling speakers, and this is actually where the voice lift is happening automatically. People just walk in, the lecturer just walks in, does his lecture, the students listen to him, the questions from the students taken from the microphones near them, and the lecturer listens their questions from the speaker which is near him. So this is how the hands-free or the Type 3 voice lift experience I was talking about. This is how it works, and this is in India. So yeah, in a nutshell, if you could connect with us one-on-one, maybe we can share more details about the specific projects that we have done here in this region and in other regions as well.
Hey,
So
Devraj, I think Polly's been dropped off the call. Let me see if there are some more questions. Yeah, I don't think there are any more questions. There have been requests for more information and emails sent. We'll get back to you guys after this session is over. We also wanted to share with you some of the architects that were mentioned or shown in these pictures that Devraj showed today. They included McCarthy Nordberg, Ray Inc., Concept Concilio, IdeaSpan, Gensler, and we have many more projects around the globe with many architects, and we'll be happy to share them with you if you contact us.
Yep. And just to remind you again, this is where you can contact india@shure.com, and we would be happy to share more information with you all on this subject. So I guess with that, I thank you all for your time and for being here. I hope it was informative for you all, and hope to be connected with you all soon. Thank you.